class, welcome to lesson 3. In this lesson, we are going to focus on significant figures and calculations. By the end of this lesson, you should be able to recall and utilize the rules for reporting calculated answers to the proper number of significant digits. Make sure you take good notes. You have your scientific not graphing calculator. Let's go. It seems silly to undergo a review of rounding, but that's what we're going to do first. When we have to round to a certain number of significant digits, you want to make sure that you identify the rounding place. You circle the number to the right of that rounding place, and you have to ask yourself, if the number is 4 or less, then you're going to just keep that number. Or if it's 5 or more, we raise the score, meaning you're going to round up. All of these numbers are significant. So now I'm going to go and approach the number from the left and underline the first 3 significant digits, and then I'm going to circle the next digit. So I know that I have 5, 2. Now this 7 is going to be impacted by the number I circled. 7 is greater than 5, so I'm going to round up. So this is 528. Now 528 is not a very good approximation for 5,277. So what we're going to have to do is we're going to have to add zeros so that our place value matches. Now if I write this 0, remember that according to the Atlantic rule, this is not significant. But it's important that it's there because otherwise the numbers don't make sense. But 5,280 is a good estimate of 5,277. So make sure that your rounded value is very close to your given value. So here in this next number, I'm going to underline the first 3 numbers. Why the first 3? Because I was told to round to 3 significant digits. And then I'm going to look at the 4th value to figure out what I do. So in this case, I'm going to have 4, 0, and because this is a 4, it's less than 5, we're just going to stay. There's no such thing as rounding down, you just stay. So 403 is the rounded number for this value. Now, in this digit here, notice that we have leading zeros. And following the Pacific rule, these zeros are not significant. Now, the first 3 significant digits are here, and the 4th is here. So when we look at these, we are going to write down a 6, a 7, and the 3 means we stay, and a 5. So 6, 7, 5, but 675 is not like 0.0067. But remember, these zeros are not significant, but they're very important for place value. So we're going to put the non-significant digits back so we can show how small our number is. So here is our value rounded to 3 significant digits. Since significant digits convey information about the precision of a measuring device, there are math rules that we have to use. So when we add or subtract, it's pretty easy. You want to make sure that your final rounded answer has the same number of decimal places as the measurement with the lowest amount of decimal places. So here you can see we're going to add these 3 numbers. The first number has 4 decimal places, the second number only has 2, and the third number has 3 decimal places. So our answer has to be rounded to only 2 decimal places. So notice here we have my calculator answer, but I have to go and look at the 3rd decimal place, which is a 4, to determine how I'm going to round my 2nd decimal place. So the reported answer should be 7.72. Not only do scientists measure, but scientists also collaborate and share their measurements. Sometimes during collaboration, you'll find that different scientists have access to different equipment, and that's why we have significant figure rules for doing mathematical operations. We'll be very lenient when you record your values to the proper number of significant digits in a calculation, but all of the multiple choice answers on our Regents will be rounded to the proper number of significant digits, and they might not answer your calculated result. Let's see if we can do some practice with addition and subtraction. When we look at this first operation, what we can notice is 10.2 is a better instrument than an instrument that can only read 21. An instrument that can read 10.2 has the ones place marked, and the measurement is estimated to be between the 10 and the 11. Whereas the next instrument used, that gives a value of 21, has only the tens measured, and the 1 is the estimate. So we're estimating that the measurement is falling somewhere between 20 and 30. So when we do the mathematical operation and we place this value in our calculator, which you should always be using, you'll notice that our calculator says that this is 31.2. That is mathematically correct, but it doesn't reflect the fact that our worst ruler can only measure to the ones place. So we're going to have to round this to the same number of decimal places as our worst ruler, which is no decimal places. So this is going to be recorded simply as 31. Of course, all measurements have units, but in these practice problems, we've left the units out. So when we look at this next mathematical operation, again, we notice that this is a better instrument because it has more decimal places, and this is a less precise instrument. Now, my calculator gives me this value, but my recorded value should only have 3 decimal places. So I'm going to underline the first 3 decimal places, and I'm going to look at the 4th decimal place to see how I should round. So since this is a 6, we're going to round up. In this example, notice that this is the ruler with the least graduation. So we only want our answer to have a tenths place. Now my calculator gives me this value, and I want to keep just the first decimal place. So what I'm going to have to do is look at the second decimal place to determine how I should round. Since 4 is less than 5, we should stay. So this should round to 85.8. One more example. When I place this value in my calculator, I'm given this, but this only has 1 decimal place. So my answer should only have 1 decimal place. So what I'm going to do is I'm going to look at the 1 decimal place I want, circle the next number so I can know how to round. So in this case, this 6 is going to cause the 9 to round up to 10, which is going to cause my number to become 5.0. It's important that we don't write just 5 because we need 1 decimal place. So although the quantity of 5 and 5.0 are the same in math, the significance of 5 and 5.0 are quite different in chemistry. With multiplication and division, instead of looking at decimal places, we're actually going to be looking at significant digits. So you'll have to count the significant digits. You can always begin counting the significant digits from the left side of the number. So in this multiplication example where it looks like we're finding area, you can see that the first digit, the first measurement 2.50 has 3 significant digits, while 2.8 only has 2 significant digits. So we get a calculator answer, 7, but we need to have at least 2 significant digits in our answer. So we are going to report 7.0. That adds the necessary significant digit. Now, it's important to note that we are only counting the significant digits in measurements in a calculation. And if we're using an exact number specifically to find an average, like if you're finding the average age of 3 students and you have to add their ages and divide by 3, that divided number, that exact number, is never part of the significant digit rule, just only measured numbers. For multiplication and division in significant digits, instead of counting decimal places, here we're going to have to count significant digits. The first thing I like to do is to put the value in my calculator. Make sure you're using your calculator. So here, my calculator gives me 12.327. Now when I look at my numbers, the first measurement has 3 significant digits and the second measurement has 2. My answer must have the same number of significant digits as the least significant measurement, or 2 significant digits. So I'm going to keep the decimal. Since the decimal place is here, I'm going to approach from the Pacific side. I'm going to keep the first 2 digits and circle the third to determine how I round. So this should just be written as 12. So even though this value is technically correct, in a multiple choice situation on the Regents, this value is the only value that will be offered because it's the correct number of significant digits. Carrying out the next operation, my calculator gives me quite a large number. Now in chemistry, even when a value repeats, you can never use the repeating bar. You must always round to the proper number of significant digits. So here I have to count the significant digits. The first value, 589, has 3 significant digits. But this value, since the decimal is present and we're approaching from the left, only has 2. So I'm only going to keep the first 2 digits, and I'm going to use the third digit to determine how I round. So 0 means we'll stay. So I'm only going to be able to write my number with a 4 and a 9. But 49 is not the same as 4,908. So what we're going to have to do is we're going to have to add place-holding zeros to make sure our number reflects its proper magnitude. These digits are not significant without a decimal point. When carrying out this operation, notice that the number 4 only has 1 significant digit. So we're going to keep the first digit and use the second for rounding. We are going to stay. So this is going to be written as 300. Again, on a multiple choice question, you will not receive the choice 312, but instead you'll receive the properly rounded number. If you take an average, this number that we divide by is not a measurement. We didn't measure 3, we counted that we have exactly 3 things. So the number you divide by, or the total number of trials of an average, is not part of the significant digits. So my calculator will give me this answer. And of course the 6 is repeating. Never include a repeating bar. You should also never include more than 4 decimal places. It's just not a thing that will happen in chemistry. Here we look at the only measured value, which is 3 digits. So we're going to keep 3 digits and use the 4th for rounding. So we should call this 1.98. So by now you should recall and utilize the rules for reporting calculated answers to the proper number of significant digits. Congratulations, you've reached the end of lesson 3. Make sure you've taken good notes. You can use guided notes or take your own, but you must have notes. They will be checked. Complete your homework on Google Classroom and bring any questions you have to class. I'll see you soon.